Your product is Glade air freshener. One clean linen-scented air freshener with adjustable fragrance from Glade. Guess the price if you dare. So, I don't know, an air freshener, let's say that it's $10. You said 10, the actual price was $1. Oh, those Glade air fresheners are much more affordable than I realized. And so then it assigns me a score, and it goes ahead and it asks me the next question. So this is great. I'm doing my manual testing here. And really, the first step there that I was doing, I was using the Reverb app, and that was a manual test that was using my voice. So we did 2 types of manual testing. Now we're going to jump in to doing some automated unit testing. So with that, I'm going to go over here, and we've got, this is our project. We've got all our tests under the test folder, and we've got them divided up into our unit tests, which is index.test.js, and integration tests, and those are end-to-end tests that we're going to go into in a moment. And so if you look at this, this should seem pretty familiar. What we've put together here are unit tests that use, this is Mocha and Kai, which are 2 very popular tools for unit testing JavaScript code. We're writing assertions that are very typical unit test assertions. But what's different is we're using our virtual Alexa component. And again, this is all just running locally, so we just give it the index.handler is basically our file path. It's the file path plus the name of the function that we get that we're invoking. We give it the path to our intent schema and our sample utterances. We support the various interaction model formats as well. But so we set this up, just all running locally. And then we're really working through the same sequence that we were there using the command line, but now it's being done programmatically. And so we're saying launch, we're saying utter, we're guessing a price. And then we've added the automation in that we're asserting at each step that the SML that comes back is what we expect. And, you know, this particular skill is not very reliant on cards, but, you know, we could certainly be adding tests to check for cards if it was using, you know, the display rendering for the show or for the spot. It could certainly be writing tests for that. Very easy to set up your tests against the JSON here. And so we have a whole bunch of tests that work through different scenarios. And overall, it's meant to very thoroughly test our skill. And how do we prove that it's thoroughly testing our skill? Well, we can go ahead and take a look at our code coverage. So this is codecov.io. This is a tool that we like for just tracking our ongoing code coverage. And there's a question here, so let me just. Oh. I don't see the question. I'm just refreshing. Well, that's refreshing. You know, there's a variety of different code coverage tools that are out there. They all do pretty similar stuff. We happen to like the graphs from codecov.io. And so then the question is, how do you mock other AWS services? So in the case of Dynamo, we have a simple mock Dynamo piece that we use that works with the Node.js SDK. That's probably the most common piece of infrastructure. For other services that are out there, I could probably show you different examples that we've done. We're using, fairly traditional mocking techniques. I would say my favorite today that I would recommend is using a tool called Knock, because most of the dependencies that you're typically working with are actually HTTP based. Knock works really great for mocking those out. And that's a recommendation I would make for Alexa skill testing, and really actually just for JavaScript unit testing in general. I could show lots of examples of how to do that. I can follow up with the person who asked that question separately. But so when we look at the code coverage for this, the green here means that this code is being executed as part of our tests. And so the bulk of our code is actually kept in our index.js file here. And we can see that each of these different code paths is getting executed. Now, code coverage, having a high level of code coverage, that doesn't guarantee that everything is going to work perfectly. That doesn't guarantee that there's no bugs in your code. But one, it gives you a baseline understanding of how well tested your code is, and you can just improve from there. Especially as you identify bugs, you add them to your unit tests, your code coverage is typically going to go up. And then also by adding it into your automated set of tests, you can ensure that you're not going to have that problem again on a regression basis. And so those are our unit tests and how they're set up with our code coverage. So now I'm going to jump back out and show you an integration test. And the integration test, it really looks very similar to our unit test. But if we think back to that diagram, here we're using the CLI, and we're talking about these two different stacks. Well, we're still talking about two different stacks. It's just now the top piece is our unit test that's calling them. And when we talk about an end-to-end test, it's this deeper stack here. So we're dealing with utterances, but instead of having this sort of low or no dependency structure, here we actually have to have our skill set up in the console. So we have to have gone and set it up here. And we can automate that step of setup, but it needs to have been done. And we're working through an interaction, just as if we were talking to a device. And so we say something like, open guess the price. And that's going to go ahead and open the skill. We say number of players. We give it names. We say $200. We're working through a whole interaction with our skill. But what's different here is that this is actually working with the real Alexa. And so it's taking the text that you see here, it's turning it into audio, it's sending it to Alexa. Alexa is then sending it to our skill. The skill is responding. It's providing a payload that's a combination of, or it's providing a JSON payload back to Alexa. Alexa then is taking that payload, turning it into audio. There's some JSON in there as well in the AVS payload. We take that audio, we do speech to text on it, and we get this nice transcript, which you can then write a test against. And actually, one part I neglected to demonstrate is this is available on our command line too as our speak command. So we can say BSD speak, open, guess the price. And so I meant to show this a moment ago, this is the same thing that's happening in our end-to-end test. And so we say open gets the price, we get a reply. That's the transcript. It says, great, contestant one, please tell us what is your name. And so we can go through that same sequence. Looks and feels similar to the unit test, but again, a lot more going on with that end-to-end test. And, you know, in terms of the dependencies, and in particular, again, the ability to test your interaction model. So because we're using text-to-speech, this is actually testing the audio and the interaction model, and it can tease out issues with the speech recognition and the NLU that's going on with Alexa. Is it going to work as well as, you know, speaking to a device directly and, you know, having a number of different parties speak to it? Probably not at this point, though we're looking at ways to make that better. But it is actually going to exercise that AI component. And it's going to exercise it during your initial testing, and it's going to exercise it on an ongoing basis. And that's, you know, these end-to-end tests are really important at the outset, but we think they're really important when you make changes to the interaction model, because it's very easy as you add new intents to essentially break stuff with the interaction model, which is obviously, that can be a problem, you know, big problem. Additionally, and we hear a lot of anecdotal reports about this, and we have our own anecdotal reports. We don't have hard data around it, but we just know that people observe that even without any changes to their interaction model, they'll see changes with the speech recognition and the natural language understanding for their apps, you know, from one day to the next. You know, and the hypothesis behind that is that there's, you know, these are AI-based systems, they're continuously learning and evolving, and they've evolved in a way that perhaps is making your skill not work as well as it did before, or it's working differently than it did before. So these end-to-end tests can be really helpful for that as well. And so how does this come together? This is really where we start to think about our continuous integration and continuous deployment. So we've set up, you know, our integration tests. We've set up our unit tests. We want to have those running on as well as our code coverage. We want to have all of that running on a regular basis, so that whenever somebody does make changes to the code, those tests get run, and we can ensure that everything is still working. And that's the job of continuous integration. Here we're using a tool called Circle CI. There's a lot of continuous integration tools out there. I like Circle. I can't tell you that it has particular features that are so different than the other tools that are out there. I mean, a lot of people like Travis, they like Jenkins, CodeShip, CodeFresh. There's a lot of good tools out there with similar functionality. And a lot of what they're doing comes down to they're going to go ahead and run your tests on a regular basis. And so in this case, we have this npm test command, which should be familiar to people who've done JavaScript unit testing. That's the standard command for running tests with JavaScript. And that's going to run whenever somebody makes a commit to the code, either on master or on any branch. And when those changes get made, and this is one of those things that's, you know, I mean, every CI tool is a little bit different, but I think they almost all do two things: is they display the result as green or red. And if it's red, you're going to have gotten a bunch of emails telling you that your build failed. And if it was a build that was done against master, maybe your whole team is going to get alerts. So it's going to try to shame you into fixing that very quickly. So that's our continuous integration process where it's running this on a regular interval. And I'll just jump in. Looking at this, this is very, let's say it's developer centric. But there's a whole bunch of stuff that these CI tools do, setting up an environment. One thing I would sort of highlight is using a CI tool versus just running tests locally on your machine. You're ensuring a pristine environment. You're ensuring that everything is, that you're not going to run into a case where it's just working on that developer's machine, which is a common issue people see, that it works for them locally, but it doesn't work on anybody else's box. And even worse, it doesn't work on, say, a production box. So you got a clean, pristine environment that you're running things in, which gives you a level of assurance about what you're doing. And that's what all that setup is. And then you're really getting the key thing, which is this NPM test. Not the most user-friendly stuff. I mean, here we're looking at the output from the code coverage. I recommend that you look at code cov instead. It looks a lot nicer. But that's what's happening within our CI tool. Now, with our continuous integration set up, we have this running all the time. We have it built into GitHub so that, we use a very typical workflow in which if you make changes, you make them on a branch, you submit a pull request. Pull requests cannot be accepted unless this test passes. So let me see if I can show one of these quickly. But these tools that we added, they provide these comments on the build. And they'll block us from merging it if there's problems. So it's part of having a really high quality, highly automated process. And most of what I'm showing you here, these are just standard things that you can get out there. This is all available. We're leveraging things from GitHub, from Circle, from CodeCov. Every one of these tools is either free and or, sort of a modest payment. So that's a continuous integration piece. Continuous deployment. I'm not going to go into incredible depth on continuous deployment right now. It is more complex. Maybe we'll do a follow-up webinar on that if there's interest. But the thing with continuous deployment is it's going to actually ensure that once all our tests pass and our code looks good, that we move it out into, that we move our code into a test environment as well as potentially into production. And so moving it into a test environment happens every time code is merged into master. And what we do there, and this is we consider recommended best practice, we go ahead and we run a deployment. And this shell script here, it basically just does some magic around setting up environment variables and tools that we rely on, in particular tools, the AWS command line and the Alexa skills kit command line. So just setting those up so that we can leverage their commands. Once you do that setup, it's pretty easy to utilize those tools to push your new Lambda out, as well as a new interaction model. And then after we do that deployment, we're going to go ahead and run our integration. So those here, we're just running the unit tests. Here, we're actually running our end-to-end tests. And an extra credit assignment for ourselves is if this step fails, to actually go ahead and back out the deployment. We have not done that step yet. But we go ahead, we do deploy it, and then we run this integration, and we're going to get notified if there's a problem with that. So after we push it out, if our integration test fails, we're going to be alerted, and we're going to know that there's a problem. Potentially if we pushed out a new interaction model and it's been broken, or it's no longer working based on changes that we made, here we have this step to let us know about that. A similar thing with prod. With prod, we use these tags. So you actually have to tag the repository using a certain format, and then that's going to kick off a deployment into prod. And so it's highly automated, but we do have this initial or this manual step because we do want to put some thought into deploying to prod. There's different schools of thought around continuous deployment. Some people like to just automate even that step into prod. If you really do a great job with all your automated testing, all your automation around deployment, that's something that you can do. That's not usually our recommendation as a starting point when you're doing automation. So that's how we have the continuous deployment set up. And from there, once we're actually live with our skill, then we can get into the monitoring component. And with monitoring, we have, with our Bespoken dashboard, which we hope you guys are all already users of, we have a neat thing called validation. And so the validation allows you to write scripts, very similar to what we have with our end-to-end test, where the left-hand side here is what is going to be said to the device, to Alexa, and then the right-hand side is a test against what it replies with. And we can run this against our skill. And so this is not very fast. Partially that's because it is just as if we were talking to a real Alexa device. But then there's also additional processing that we're doing. But we can see it just works its way through the conversation. All right. So that's interesting. So this is actually running against my laptop locally because I have it set into dev. So apparently my laptop is responding too slowly. So you're getting these errors. Really, I should have this pointing against a Lambda or against something that's deployed as a server, not against my laptop. That's not a good end-to-end test. But this validation script, one of the things that we're very excited about is we are very soon adding, besides our existing monitoring, which does a ping with either just a simple payload or a custom JSON payload, we're adding this into our monitoring so that you can run these scripts on a regular interval. And that's a very neat feature that we're very excited about. It's not available yet, but we expect that will be available soon. And we think that's a really important part of monitoring skills effectively. And that's going to give you testing both around when you're making changes, but also ongoing testing, around the speech recognition, identifying any potential issues with that, as well as just any outages, because it is working through all the infrastructure. So using these scripts with monitoring is really helpful. Additionally, from a monitoring perspective, we have a great logging capability that's in here. And this is going to show you the full history of the interactions for a skill. And we don't have any recent errors here. But it's going to make it very easy to find any errors that are happening with the skill on an ongoing basis. And so if you discover there's something wrong with it on the monitor, you get an alert, you can come in here and look for the specific error or exception that happened. And so very helpful tooling for that. So I know I went through a lot of stuff there, and it's 1:45 now, and we wanted to leave time for questions. So before I go any further, questions for me, things that you would like me to talk more about or would like to understand better. No questions yet. I'm just looking at the. So I see in the chat window, Kane says, yeah, could you just run through all that again, please? So, I mean, it sounds like that's a little bit of a joke, but that I appreciate that feedback. And we are really working on how to explain all this well. I hope we're succeeding, but we appreciate feedback around, oh, is there something that was confusing? Is there something we're not explaining well? We have this nomenclature, virtual Alexa, virtual device. I hope that's clear. We're talking about emulators and virtual devices. It's really important to stuff, and the distinctions are important. We hope we're explaining it well, because I know it can be a little bit subtle. At least at the outset. Once you get into using it, they are profound differences. I see Adam asks, any sort of performance hit with the monitoring in place. So with our logging piece, if you add that in, that is going to add about 80 milliseconds based on our testing to transactions. We do routinely test that or test that from a performance basis. So it's a slight hit. And that's, I should say, that Lambda, where it does, Lambdas have this thing where you can't actually do real async programming, so you have to wait before you can flush a request. If you're not using Lambdas, it's actually a fire and forget, so there's no performance hit. But with a Lambda, it's going to add about 80 milliseconds. That should not be significant to your overall skills performance. If you're working with Dynamo, for example, it's going to be about the same amount of time as an interaction with Dynamo. And I see Kane says, not a question from me, but just wanted to say that it was really interesting. I'm beginning in all this knowing that you can run automated testing like this is really handy. Glad to hear that. We think automated testing is fantastic. And I would just highlight, since there's not other questions, that doing your unit testing early on is going to save you a lot of time. If you think about what it takes, if I go over to if I've got a bug in this step, if you're manually testing this, either using our command line tools or device, if you have to work through these other 4 steps before you can get here and look at that bug in the code, and God forbid if it's actually based on some branch, it's not just at this step, but it's a specific set of preconditions for these steps. Geez, it can take you a while to chase this down. Might take you a day. Whereas you write up a nice unit test like this, doesn't take very long to set up the test, and you can isolate a bug at this stage in your processing. I don't know. Maybe it's going to take 5 minutes. Maybe it's going to take an hour, but it's going to go a heck of a lot faster. Can this be used to load test skills? I would have to think about that. Maybe it's probably not the first approach I would take. I would probably follow up on that one with the suggestion. I have not been using this for load testing. It's probably a component in a load testing mix. But there's some additional tooling that I would use in addition, besides this. I'm used to using JMeter. There's products. I think it's Artillery that I've looked at. I have not used that, so it's not an endorsement, but Artillery is a good load tester for JavaScript. Use something like that in concert with the virtual Alexa piece. That would be probably a good load test. I see there's a question around lambdas that interact with multiple AWS services, DynamoDB, etc. Any recommendations on how to mock those interfaces? My main recommendation is to use knock, but I'll follow up with you separately on that. I do think knock is just, if you're writing your unit tests in JavaScript, that's the best tool for best and most reliable way to write good JavaScript unit tests without having too many dependencies. Is Lambda another question, is Lambda the preferred environment when working with Bespoken tools? Any success stories outside Lambda environments? Absolutely. Lambda is the environment we use the most, but or at least we demonstrate with the most. I am a diehard Docker person, so I do have to kind of force myself to use Lambda. I'm not complaining about Lambda. It's a great technology. We love serverless stuff. But there's a lot of examples of where we use this with Docker environments. I think that, doing continuous integration, doing all the automated testing piece I was showing, doing your continuous integration, continuous deployment, using Docker, using, whatever other environments you have, we think that, that can work great. And I'll follow up with you on some examples for that, Adam. But no, I mean, we do talk a lot about Lambda, but certainly we use other environments a lot. I would say to a great deal of success. I should also mention we have the polls going on over here. Please do fill out the poll if you have a chance. We have a few questions in there. It's useful information for us. And feedback also on these webinars of any nature is useful to us, I should also say. I see Kane has given us some very nice praise, but if you hated this webinar, if you thought it wasn't useful, or if you thought I should have talked about something else a lot more, we'd love to hear that as well. Any feedback is welcome. I'm just looking at Twitter. I see people are tweeting about our webinar. That's great. Just while waiting for other questions, I'll just sort of return to the question about load testing. Artillery. I mean, this is not one I've used. I've just looked at it. You can also always just kind of roll your own unit tests. But something like this in concert with our virtual Alexa piece that makes it easy to write a JavaScript Alexa interaction, I would guess this would work nicely. That might be another sort of blog for us to write, showing an in-depth load test with our virtual Alexa component and something like artillery, which just came to my attention as a load testing toolkit that has good support for JavaScript. Obviously, there are lots of JavaScript unit testing frameworks out there, or sorry, JavaScript and just general load testing frameworks out there. So you don't have to use that one. But could be interesting. I have a question, and maybe we can put it into the polls there. But just, I'm interested if people would like us to do like a weekly office hours on this. We hadn't done webinars prior to this. We've been very happy with how it's gone. Both with the attendance and the engagement. And it's been a good chance for us to interact with people. We hope to sort of spread the word about what we do, and also just learn a lot. So we're contemplating doing this on a regular basis. Be interested in feedback on that, and if people would want to attend for that. Yeah, maybe not weekly, but monthly would be cool, is a comment from Tom. Yeah, I mean, I wouldn't attend one every week. Maybe we can have it every week so people can join when they want to. But it could be a useful resource. We're getting close to the end here. We're going to keep this open till 2 p.m. But ahead of wrapping this up, I just want to thank everyone for attending. Thank you for the questions. Again, know that we're going to be sending the video for this as well as the slides, making that available after the webinar. And we hope you found it useful and that you learned something. All right. Well, with that, we're going to wrap it up. I see Tom and Adam. Thank you, and thank you to everyone for attending. And have a wonderful holiday.